section 9.7. In section 9.7, we're going to be talking about solving inequalities. So, section 9.7 is titled Solving Inequalities. Now, in our last class together, we talked about some vocabulary. We talked about the word solve just means to isolate the variable. In math, isolate means to get by itself. And we talked about how to solve equations. And I mentioned PEMDAS that you probably learned about in high school. And when teachers teach it in high school, generally we go this direction when we're simplifying. And we go this direction when we're solving. We walked through some examples in the previous sections with that. With inequality, there are a couple extra steps that we have to do or just be aware of. One additional steps when compared with equations one of them is whenever you multiply or divide across the inequality by a negative, we switch the inequality. How many of you knew that before? All right. So, you might have been taught that before, but you might not have been taught why that is. So the reason why it is because on a number line, as the positive numbers increase in magnitude, so like 1, 2, 3, 4, the numbers are bigger this way. But it's the opposite with negative numbers. You don't have to know this, but I just like to give you a little context instead of just telling you something and not giving you any explanation. In the negative direction, the numbers are still getting bigger as we go to the right of the number line, but obviously -1 is bigger than -3, but it's reversed for the positive numbers. So if I tell you 1 is less than 3, and I multiply by a positive number, 2 is still less than 6. I mean, that's true. But if I were to multiply by a negative number, -2 is not less than -6. It's actually greater than, because negative numbers work the opposite way on a number line. So that's where that rule comes from. So that's one additional thing to keep in mind. Something else to keep in mind is that when graphing, if you see a sign like this or like this, we put an open circle on the graph. Or we use parentheses, and I'll explain this in a minute. And if we see a symbol like this or like this, it's going to be a closed circle on the graph, or we use brackets. So I'll give you a second to copy that down, and then I'll show you with some examples. So I'll give you some examples here, and I'll just ask you to solve and graph the solution sets. First example we'll do is 2x plus 3 is greater than or equal to 11. Now, usually with an equation, we talked about 3 types of solutions. We said a conditional equation has just like x equals 2 or something. We also had all real numbers where you got 2 equals 2. And there's also examples where you can get no solution where it's like 0 equals 5. With inequalities, typically you get an infinite number of answers. So you're not just going to get x equals 2, you might get x is greater than 2. So any number greater than 2 would be the answer. So with this, we're just going to solve it like an equation. We'll subtract 3. 2x is greater than or equal to 8, and then divide by 2. Any answer greater than or equal to 4 would work for this inequality. And the way that we would graph the solution set is on the number line. You don't have to draw out a whole bunch of tick marks. I mean, if you just want to put 4 right in the middle, do a closed circle on it, and then follow the direction of the inequality. So if it's pointing to the right, then you graph it to the right like that. What this tells you is that any number greater than or equal to 4 would satisfy the inequality 2x plus 3 is greater than 11. What that means is 4 is greater than or equal to 4. So if you were to plug 4 in here, you'd get 11 is greater than or equal to 11, which is true. So that means that 4 is a possible answer. You could also use 5. If you were to plug 5 in for x, you'd get 18 is greater than or equal to 11, which is also true. And you could keep plugging in values for x. Any x value greater than 4 would work. So the way we write our answer is just like this, right? And that would be the graph of it. What if we had 4x minus 2 is less than 6x plus 8? You came in a little later today, just make sure before you leave that you sign in my sign-in sheet. It's up on my desk, okay? At some point before you leave. All right, well, the way we solved equations was we tried to get all the variables on one side. So what I'll do is I'll subtract the 6x to get it on the left. Then add 2. And divide by negative 2. But this is one of those times that we talked about earlier, where if we're dividing across an inequality by a negative number, we have to switch the sign. So any answer that's greater than 5 would work. You can't use negative 5, but you could use negative 4, negative 3, or any number that's greater than negative 5. And a couple more in this section. Let's say if we had negative 2x plus 6 is less than or equal to 3 times x minus 4. Just like with equations, we could distribute first. So we get negative 2x plus 6 is less than or equal to 3 times x and then 3 times negative 4. And then we want to get all the variables on the same side, so we could subtract the 3x on both sides. if we subtract the 6, and then divide by -5, we get x is greater than or equal to 18/5. Now, we don't want to use decimals, and you don't want to say 3 3/5. You want to use improper fractions. So 18/5 would be a good answer. The way that we would graph this is you could just put a point at 18/5, close circle, all numbers over here are greater than or equal to 18/5. And the last problem from this section is, what if we had -2 times x plus 1 minus x plus 3 in parentheses is greater than -4? There's no number in front of a parentheses. You could always just put a 1 there and then distribute that. This problem we have to distribute a couple of times. And we get -2x minus 2 minus x minus 3 is greater than -4. Then combining our like terms, -2x minus x is -3x. -2 minus 3 is -5. So once we combine our like terms, we get this. Adding 5. And then dividing by a negative, we have to switch the inequality. So this would be our best answer. We're going to put an open circle on -1/3 and then graph to the left.